demo, I'll show you how to run moderation analysis using a process add-on in SPSS. I've already installed that module, and I'm also using the same data set as the one we used in the lab. So in this data, we have three variables. So we are interested in whether the relationship between borderline personality disorder symptomology predicts the cortisol level or reactivity, and if PTSD symptom severity moderates that relationship. So in order for me to run that analysis, I'll go to Analyze, Regression, and the Process module here. And I am going to add, since the cortisol level or reactivity is my outcome variable, that's what I'm going to move it to. Borderline symptom severity is my independent variable, and PTSD is my moderator. Now, if you look at the templates file that comes with the process files, it will specify that a simple moderation model is actually model number 1. So that's what we're going to select. In options, we are going to mean center the products. We are interested in the heteroscedasticity, consistent standard errors. We also want to generate plots. Hit continue. And for conditioning, we're going to keep mean +1 and -1 standard deviation. This is basically used to run the simple slope analysis. And then we're also interested in Johnson-Niemann technique, basically testing for significance beyond the points of just mean and standard deviations. So we'll hit that. Multi-categorical, we're not going to be using this menu since we don't have a categorical variable, but this menu is used when you have either a categorical X variable or a moderator variable, and then you can specify what kind of contrast codes you want to run, and I'll show you that in the other demo. So for now, we don't need this. Long names, use this when you have data files with variable names longer than 8 characters. Is always a good practice to always allow this, and then it won't give you errors if the variable names are long. And instead of hitting OK, since I need the syntax, I am going to hit paste, because if I hit OK, it doesn't provide me the syntax. So I'm going to hit paste. And here I have a really long syntax or code, which I am not interested in, but it is required for it to run. What you want, however, for your homework, for example, is this portion of the syntax, which basically tells which options you selected and which you did not. So 1 represent the options you selected. Well, this one is actually model number, and then 1 represents for other options as selected options, and 0 is options not selected. For me to run this, I need to right-click it and run all. And it sometimes takes a couple seconds. And now we have the output. So going through it, we'll just go through it top to bottom, and I'm just going to talk about what the information is provided and how it's different from regression output, and also what are the additional things that it has provided us that we have been doing by hand. So on top, it tells you your model number and what are the variables and what are the associated, whether they're X or Y or moderator. Then we have sample size, and then we have this block, which is similar to model summary table, our coefficients table, and also the ANOVA table. The model summary table tells you the R-square value, so overall how much variance is explained by the model. It gives you the F statistics. And remember, this information is for the model that includes all of the variables in it. If you remember, in regression outputs, you would have, since you run 2 models, you would have 2 blocks for model 1 and model 2, where model 2 always included the interaction. So in here, we don't have 2 different models. We just have 1 model to work with. So this is basically the overall ANOVA, F statistics, ANOVA table statistics, so the F statistics and significance related to that. This block here is just like the coefficients table and represents the information that you would find in model 2 block. And since there is no model 1 versus model 2, you basically look at whether the interaction was significant. So that tells you that there is something going on there. And if it is significant, then you would look at the simple slope analysis and Johnson-Niemann, and you would report that. But if it's not significant, here, see, it tells you it's not significant, and also tells you how much of a change, so R-squared change for when interaction is added in the model. So you would report that if it is significant. And then the rest of it is the same, except for the fact that this table does not include beta or standardized coefficients. It only include your unstandardized coefficients, so be mindful of that when you're interpreting. And if you need betas for your research or for your paper, then you would have to convert those values to betas. And then you already know how to do that. You've done that in past homeworks. It also tells you what the interaction term is made of. So just remember that it is centering the variables that are continuous here. So both of these are continuous, center both variables. And then below this, and again, you would read this information, obviously, when interaction comes out to be significant. Other than that, you are not interested in this information. But this shows you the simple slope analysis. So for PTSD with a negative 3.9342 score or low PTSD symptomology, the effect comes out to be significant. With average PTSD score, effect is significant. And for high PTSD score, it is not significant. So basically, we can say that for low and average levels of PTSD, we can significantly predict the relationship between our X and Y. Now here you would note that these values are different. With plus and minus 1 standard deviation, you would think that the absolute values for these two, low and high, would be the same, except for low would be a negative and the high would be a positive. The reason here is probably the low value. There was no value that was at negative 4.507. In that case, process grabs the lowest available value, and it would happen the same way if it did not have a 4.5079 value. It would just grab the highest available value. And if you look at the note, it basically tells you that for at least one moderator in the conditional effects table, above 1 standard deviation below the mean was replaced with a minimum, because 1 standard deviation below the mean, it's outside of the range of the data. Okay, so that is that. You would report that in your analysis, but then you also have a Johnson-Niemann test here, which tests for multiple other values for PTSD and checks whether the effect, whether we can predict on those PTSD scores the relationship between X and Y to be significant. So, for example, it starts from the lowest value available, which is negative 3.9342, and tests for the significance, and we see that it is significant. And then it conducts multiple regression tests for PTSD scores and go up to the highest one available, which is 10.8658. Now, looking at the p-values, we see that these come out to be significant until we get to negative 8459. Now, this basically tells you that our zone of significance is right here. So between values negative 3.9342 and 0.8459 inclusive, this is our zone of significance. This is where we can significantly predict the relationship between our X and Y. However, as the values for PTSD increase, or the score on PTSD symptomology increases, we're not able to predict significantly. So this is kind of giving you the same information as simple slope, but is getting more into into specific values and giving you a lot more detail. So right now, this is the only zone of significance. That is the one zone of significance we have. If we have multiple zones of significance, we would have multiple values reported here with how many percentage of values below or how many above that are significant. And then you would actually report for each one of those. Just make sure that you are reporting for the zone of significance, not the zone of non-significance. And lastly, we have data for plotting. If you remember, when we were doing calculations manually, we were taking our 3 regression equations for low, average, and high. We were actually calculating those regression weights for two scores that we picked, so random scores, so 0 and 10 we have done in the past. So this is the same thing that the process is doing, and it's taking actually 3 values and then inserting them into each of the regression equations, so low, medium, and high, and then coming up with the scores. And then these are the numbers that can be used to plot our chart in Excel. But in order for us to plot these values, we don't have to do anything manually. All we need to do is actually select all of this information. So let me try doing that. We would select data list, and then up to this section, we would copy this, and I am going to go to new syntax and paste this information here. So once I do that, make sure I select the whole thing, and then I hit run. What this does is then it gives me a plot, which basically gives me the 3 points plotted for each of the regression equations. So the blue ones show PTSD, low PTSD, the green one is average, and the orange ones are high PTSD scores. So you see there's kind of an interaction going on there. You can also use these values in Excel to plot, but again, you cannot just copy and paste and work from there. You have to organize your data. So you would have your, for example, low in one row, all 3 values of row in one row, average in the other, and so on and so forth. And we have talked about that in class, and you can try doing it. But the data is there. All you need to do is organize in a certain format in a certain way, and then you are able to do it. Now, when you copy, if you try to copy it from here or from syntax, it's not going to paste correctly in Excel anyways, because it's copying it as a text. So when you run this, what SPSS does is actually give you this information in terms of a table, and then it becomes easy for you to plot this information. All right. So let's get back to our output that we were looking at. So let's see if there's anything else. So at the end of the analysis, it tells you which variables were mean centered, and it tells you the confidence interval level. It's just the confidence interval level, which is 95%. And basically, this is how you run and how you understand the output for simple moderation model using process. And I hope this was helpful.